Great, thank you. Hi, welcome all. I'm Len Theivendra, the Mono2Micro architect and lead. And today I'll be giving you an overview of IBM Mono2Micro and also go through a live demo trying to refactor a typical Java EE application using the Mono2Micro toolset. All right, let me go through a few slides first, and then we'll jump right into the live demo. Okay, so what is IBM Mono2Micro? So it's a AI-based semi-automatic transformation tool to refactor monoliths into microservices. And what you start with is your monolith application and its source code. And then Mono2Micro's tools lets you do both static and dynamic analysis on the monolithic application. And the AI engine will then come up with recommendations as to how the application can be partitioned. And it comes up with two kinds of partitioning schemes based on business use cases as well as natural seams. I'll explain that in a bit. And after the AI recommendations are produced, you can view them in our UI and further analyze and customize them to your liking. And also then use our code generation tool that will generate a lot of the starter code for you in order to implement these partitions as microservices. So a few more details. The monolith starts here. Both static and dynamic analysis. Our AI is unsupervised AI based on ML, and it uses hierarchical clustering algorithms to analyze both the static analysis and dynamic analysis data. And then it comes up with the recommendations for which the code gen can be used on. All right, let me go to this slide now. So in terms of how IBM Mono2Micro fits into the overall AppMod journey and toolset from IBM, of course, we have the Transformation Advisor tool and the WebSphere Application Migration Toolkit tool, all part of WebSphere Hybrid Edition. And they let you re-platform your monolith applications, migrate from version to version amongst WebSphere and Liberty, all to get on Liberty running on the cloud as your target modernized runtime. Whereas Mono2Micro examines a single monolithic application, comes up with the partitions, and once those partitions are done and code is generated, you can still use the migration toolkit tool if there is some WebSphere migration tasks that need to be done, or go straight to Liberty on the runtime. Okay, so a few words about AppMod in general and the approaches. Of course, we have the lift and shift, which is moving on-prem VMs to VMs in the cloud. This, of course, is the simplest approach with no application code or configuration changes usually in most cases. Replatforming, that's where our TA tool comes in to containerize monolith applications. TVOS to Open Liberty Platform Shift may need some code changes, but usually minimal as well. A less common approach is the repackaging mechanism, attempting to split monoliths into more than one component according to the underlying programming models. Of course, this is a limited domain of applicability, and the splits are based on the programming model, and that may introduce further complexities. Refactoring to real microservices, that's the space that Mono2Micro plays in, and this can be challenging, of course. It is not a simple task, but can potentially provide a lot of ROI. Okay, so let me now jump into this slide here that gives an overview of how the Mono2Micro tools work and the flow of how to use our tools. So you start with your source code for the monolithic application, and you run our tool that does the static analysis on that application source tree, as well as instruments it. So there's two things that come out of this. So first is, all based on the static analysis, a lot of information about the code structure, what the classes are, the variable types, the methods signatures and whatnot are gathered, as well as existing class dependencies can be inferred. And in particular, Mono2Micro cares about two kinds of class dependencies that already exists in the monolithic application. First is what we call class containment dependencies. This is when one class uses another class as a state variable or within its method argument types or return types. Of course, that establish a dependency between classes that we are interested in when breaking up the monolith. And the other kind, of course, is Java inheritance, when one class depends or extends from another. That, of course, is another dependency that needs to be taken into account. So apart from that, in terms of instrumenting the source code, what we then ask the user to do is to rerun the monolith, like build a monolith, the instrumented monolithic application, and then run it through various business use cases or typical user scenarios. And this is in order to exercise as much of the monolithic application's functionality as possible, and in turn exercising as much of the code base as possible. And once that's done, out of that will come a lot of runtime traces that can be collected on the application server side. And then we have this other bit of information that we call business use case context, which we use another Mono2Micro tool for, that essentially adds some context to these use cases. So to collect such information like the use case names and the exact start and stop time of each of the use cases. So how all this plays together, I'll explain a bit more in detail. But essentially, this is the data collection phase of using our tools, both static and dynamic. And once all of that is fed into our AI engine tool, which is our AI analyzer and recommender, it then does its analysis based on ML. And it comes up with two kinds of recommendations as to how to partition the app. One of them being the natural seams partitioning scheme that takes into account all of these kinds of collected data, both the static analysis as well as the dynamic, and then the partitioning by business logic that only considers the use case information. So these two partitioning schemes, I'll talk a bit more about those. So natural seams, it basically attempts to break up the monolith along its natural seams, and it's a less disruptive way to do so. And it takes into account existing code dependencies in addition to the use cases. So it's a more conservative approach to try to break up the application for initial partitioning recommendations, whereas the partitioning by business logic purely only takes into account the use case data. So this tends to be a more disruptive approach, but we think an ultimately more useful way to partition your app, because the partitions are aligned to use cases and islands of functionality that the AI engine observes. All right, so quick word about the application I'm going to use my demo on. It's the Datator app. It is a typical Java EE app available in the open source. It's used to simulate stock trading, and it makes use of typical Java EE components like JSP, servlets, EJBs, JPAs, and a database. And it comes packaged as a year. So that's what we're going to use for the demo, and let's dive right in. So using this slide again as a reference, we're going to start with the source code here and now run our AI analysis tools. So let me jump into my VS Code here, and this is the source tree for Datator. As you can see here, there's a subdirectory for the year module, then there's one for EJB and web that contains all the source code for those. And alongside those, we have various build config artifacts, Java EE config artifacts, as well as server config artifact files. All right, and a quick word about how our tools are packaged. They're available in Docker Hub, especially the trial version, which is free for 90-day use. And they come packaged as containers, and they're runnable on the command line. I have my command line cheat sheet here that I'm going to use for the demo. And they're all Docker run commands for all of our tools. And our UI as well is backended by a container. But for now, I'm going to copy this command line, which runs our static analysis part of the process. So I'm going to kick it off here. And it takes as input the source tree of your monolith application, and that's it. So once it gets going here, you're going to see that it's going to go through each and every Java file in the source tree and just the Java files. And as it does that, it'll start to collect the static analysis on the code base, as well as instrument that Java file. And here it goes. Should be done anytime soon. This app is about 100 classes, so it goes by pretty fast. All right, it's done going through all the Java files. It's doing further analysis, and now it's done. And what did it do here? So it basically created another directory with the same name as a monolith source tree, but with the -klu extension. And in there, it's pretty much the same files again. There are these two JSON files that got generated that I'll go over in a second that contains all the static analysis that the tool collected. But I'll quickly show you an example of how the source gets instrumented. So going down to typical class in the monolith here, this is the trade action class. And I go to the buy method here for buying stocks. And as you can see here, what we've done, we have instrumented a entry point as where the code is entered into, where we log the exact time in milliseconds, as well as the ID of the thread and some other information, and do the same as we exit out of the method. And this is pretty much what we do across all the classes, the instrumenting the entry and exit in and out of methods. All right, so coming back to this slide quickly here, now we have done this part. Let's do some dynamic analysis now with the instrumented monolith app. So in rebuilding that app and running it through the use cases, what we're going to do is our tool called Flicker, which is going to capture use case information as we go through it. So let me show you an example of that. That also comes packaged as a Java file, which we can run on the command line here. So let me just kick it off. And it's going to ask me, okay, what is your label for the first use case? So I'm going to say user login. Once I've started that off, I'm going to now go into my actual running instrumented monolith application and go through the typical process as an end user of the app as to how to log in as a user. So I'm just going to press login here. And now I'm done with that use case. Come back here and I'm going to say stop. Now it's captured the exact start and stop time of that use case, which I called user login. Let's do one more. Let's buy some stocks. So I'm going to say buy stock. Come back into the app. And again, go through the typical motions that I would in buying stock in this app. So I go to the quotes trade section here, pick this stock, buy 120 units of that. And I'm done with that. Come back here, say stop. Again, it captures the start and stop time for that use case. I'll stop out of here for now, and I'll show you a more completed version of what I collected for this app. So bring up that file. And this can be one or more JSON files. And as you can see here, I've gone through and collected a bunch of use case information. And that tool that I just ran essentially just is acting like a stopwatch, capturing the use case label as well as the start and stop time. Now, as you can imagine, as I was running through all these use cases, because of the instrumentation, a lot of tracing was being captured on the app server side. So if I go and look at the logs that came out of the server side, so in this case, I happen to be running my monolith on Liberty itself. Per all the instrumented code, this is what got captured. So all the exact entry and exit times out of each and every method in all the classes while I was running those use cases. So now Mono2Micro has a way to correlate the exact code that got executed for each of these use cases, because it knows the start and stop times for the entire use case, and it knows the exact time that each of these methods were entered into and exited out of. So that's all going to feed into the AI engine that uses clustering algorithms, and it's a spatio-temporal clustering algorithms. And the temporal part specifically I want to speak about here is the flow of code that it's going to be able to observe now due to the trace information that's being fed in. All right, so we are now done with the collection part. We have all three bits of information here that can all be fed into the AI engine. And that command as well is runnable like before as a Docker container. In the interest of time, I'll skip that and I'll go right to the end product. What the AI engine will produce once it's run, it'll produce some reports, and it also produces a JSON file that contains a lot of the information that's going to be then used in our UI to view the recommendations as a directed graph. All right, so let me jump to our UI now, which is here. So once you start up our UI, this is how it starts off like, and you load in the JSON file that gets generated by the AI engine. That comes off like that, finalgraph.json, and then here it is already preloaded. Okay, so we start in the UI and we look at the partitioning recommendations now from the AIPL tool. Let me quickly go over some of the basics of the UI here. Each of these circles represents a class in the monolith, and the boxes are the partitions that the AI has grouped them into. So in this case, for the natural themes partitioning recommendation view, we have 4 partitions that the AI came up with. There's also this unobserved partition. I'll speak about that in a bit. But in terms of how the UI works, let me just zoom in a bit more. You can zoom in and out to get a better view. If you click on a class, let's say action message here, it shows more detail on the side here as to what use cases that class was observed in. So this is where it's important when you are collecting use case information to provide meaningful labels to the use cases. Now, a quick word about the use cases there I wanted to mention is that, of course, trying to exercise as much of the monolithic application, especially if it's a large one, becomes a pretty labor-intensive effort to capture this data manually, which you can still do. But we also provide the source code for the simple tool that captures this contextual information. So if you have existing automated test suites, especially if they're Java-based, you can integrate the code right into the test suite to emit this file automatically as the automation is going along with the test cases. So obviously, it'll be great if the test cases are more of a FET variety where actual functionality is exercised end-to-end as opposed to unit test type functionality, because that's not the most useful information to provide to the UI engine. But just wanted to quickly point out that this can be automated as well, rather than doing this manually. But I happen to do this manually for this app. All right, coming back to the UI here. Yeah, so you have more information on the side here. If you click on a class, it also highlights all these edges. Now, what are these edges, these arrows? So these are directed edges indicating flow of code that Mono2Micro observed in the use case data that he provided it. So if I hover over this edge here, it says that Mono2Micro observed 7 times flow of code going from this class to that class. And more than likely, that what that means is that this class was calling into methods into here, and that is the most likely case, and that's why we call them runtime calls. Now, another way that this can be observed, flow of code, is when flow of code exits out of a class, goes into the application runtime server base core, and comes out in another class. That's also sometimes likely, but more than likely, these are method calls, right? So that's those are the basics of the UI here. Some other things, you can drag them around, move things around, collapse partitions to make it better, to be easier to see this as a whole, expand them again, and also filter out partitions that you don't want to see or you want to see. So just some basics of the UI here. Now let's speak about the natural seams partitioning scheme. As can be expected, natural seams recommendations tend to result in 1 or 2 large partitions and some smaller partitions, because again, the AI is attempting to be mindful of the existing code dependencies. So it is a less disruptive way to partition the app, and that's what we see here in the UI here. If I jump into the business logic view, here we see 5 partitions that the AI came up with. And this is a more disruptive way with more inter-partition crosstalk being seen here. Essentially, runtime calls from classes across partitions here. And that's to be expected because it only considered the use case data, and it tried to group, according to the clustering algorithms, classes that it felt belong together. So I'll speak a bit here about cohesion and coupling. So coupling is one thing that Mono2Micro tries to minimize when it comes up with these partitions. And what coupling speaks to is the amount of crosstalk or runtime calls across partitions, and also the call volume. For example, if you had only, like, say, for example, this edge here, it says that this was observed 142 times. So what that means is that there's still a tight coupling between these partitions. And that's something to be mindful of when you start to implement these partitions and try to minimize the coupling here. And that essentially means rewriting of code such that this crosstalk doesn't exist anymore, or moving classes together into the same partition to avoid that cross-partition talk altogether. One other thing that you can gain is insights into your monolith itself from this analysis, right? For example, I can click on this class here called log. As you can see, it's a heavily trafficked class. A lot of calls are going in and out of it from various partitions. And from my insights into the monolith already, I know this is a POJO. So this then likely points to, hey, this log probably belongs in a utility module that can be packaged with all the partitions rather than acting as a service. So that's one kind of insight that one gains, like potential utility code as opposed to potential microservice code. And then the other kind of insight I'm going to speak about is based on the unobserved partition. So let me expand that here a bit. As you can see here, there's a lot of these ping classes being classed under the unobserved partition. Now, what are they about? If I go back to my running monolith here, the monolith just happens to come with this section in the UI here that lets you test out bits of functionality within the application itself. Now, as I was collecting use case data, I didn't bother to go through and run through each and every one of these. So what Mono2Micro says is here, okay, I know these classes exist in your monolith source tree because I saw that in the static analysis input, but I did not observe them at all in any of the use case data that you provided. So what does this mean? It could mean one of two things. It could mean that either the classes in here are potential dead code, that is where you have exercised as much of the functionality of the application as possible, and still they did not get hit. So points to potential dead code, or it points to the fact that you did not cover enough use cases for your monolith to cover all of its functionality. So again, insights can be gained just into the monolith itself in this exercise of refactoring with Mono2Micro. All right, let me just pause there to see if there are any burning questions that are on the chat that I can answer. Marika, let me know. If not, I can keep going.
Yeah, you can keep going.
All right, cool. Okay, so what do we have now? So we have two kinds of recommendations that the Mono2Micro's AI has come up with: business logic seams partitioning and natural seams partitioning. What else can you do here? Now you can take this as a starting point to say, okay, you know what? I like one of these two. I'm going to use that as my base to try to go forward on my refactoring journey in order to partition my monolith into these partitions, and then try to fix up and rewrite code in order to try to implement them. Or you can say, well, I like these partitions, but you know what? I like to do some tweaks, some further customizations in order to better refine these partitions to my liking. And that's where we provide the custom view in our UI. Now, when you start off in this custom view in our UI, it'll ask you, do you want to start with the business use case view or the natural seams view? And once you're in one of those, you can now move around classes, create partitions, delete partitions, rename them, so on and so forth. So let me jump into this custom view that I already have for the Datator app. As you can see, it's slightly different, of course, from the initial recommendations. So now I'll explain what I did here. Firstly, some mechanics again. So once the edit button is toggled on, you can move around classes. So if you think, you know what, I like this class here, but I want it to be in partition 3, so I can just drag it across and then it places it in there. Or you can move it into the blank space and it'll start to create a new partition for you, which you can further build upon, or you can move it back and it'll remove that partition. So this is the kind of drag and drop editing functionality that the UI provides. Now let me explain as to why I partitioned it this way, or why I customized it this way. So I said, I like the business logic view as a starting point for my refactoring of this app. I noticed that a lot of my backend functionality in the app has been grouped into partition 1. So I like to keep it that way. I like to keep my entity model, my JPA beans and EJBs in one partition for now, at least as a first step. And I also like the other partitions, but I want to create one partition to house all of my front end code. So all of these servlets and these other unused classes that are mostly UI classes, I feel like they could be best fitting in one partition. So that's what I did here. I created a web partition, basically, moved all of my front-end UI code into that partition. And I also moved some servlets that Mono2Micro had initially placed in these other partitions into this one, because I know the way servlets work, all of these HTML files that are on the UI side that refer to these servlets, the servlets need to be running on the same app server instance. And because these partitions are likely to be running as on one app server instance, I need to move these servlets into that. So that's what I did here. All these classes on the right here are servlets. I moved across to the web partition. One other example of move that I did was, if I come back to the business logic view, you'll see, although all of the JPA beans got placed into partition 1, it did place one of them in partition 3. And because I wanted to keep my entity model together, I moved the holding data bean, entity bean into partition 1 as well. And I did some other moves as well. And that's all detailed in my article on DeveloperWorks that goes through all of the classes and why I moved and then from where to where. So do give this a read for a more detailed write-up of this refactoring on this sample application. All right, coming back here. So now I'm pretty happy with the way I've customized this. Now I'm ready to go to the next step. And the next step could be one of many things. I could say, okay, I take this and I now start to try to implement these partitions on my own, taking the existing monolith code and rewriting as necessary, whatnot. Or this is where the user has a choice to use Mono2Micro's code generation tool, which will implement a lot of the function, the plumbing code and the starter foundation code for the microservices to implement these partitions as is. So let me speak a bit about Mono2Micro's code gen and the philosophy behind it and how it works. So the main premise of Mono2Micro's code gen is it says you get to keep your monolith classes completely as it is without change, yet distribute them across these partitions either from the customizations view or the initial recommendations from the AI. And Mono2Micro will then generate a lot of the code that facilitates these interpartition communications. And this is as a first step to get your partitions up and running, where you can then do further analysis and debugging to refine these partitions on your journey to independent partitions, where these crosstalk and interpartition calls are minimized, if not removed completely, and these microservices stand alone. But at least as a first starting point, especially in order to keep the monolith code as it is, we need to facilitate these interpartition calls that could happen. And that's what Mono2Micro's code gen generates. It's based on the RMI philosophy, so I'll explain that now. Jumping back into my VS Code here, let me close out some of these windows. So let's go for an example. So what does Mono2Micro's code gen do? So what it does is it takes your customized partitioning or your initial partitioning that came out of the AI as one set of inputs, and the other input, of course, is the monolith source tree that was provided to the static analyzer tool. The same source tree again. It uses as input. And what it'll do then is it'll create a directory for each of the partitions. So let me jump right into that one here. And within each partition, it maintains the same directory structure as the monolith source tree. And that's for a reason that'll become clear in a second. After that's done, it generates each of the code, all of the monolith classes that belongs in each partition. It places them in there and then generates the wrapper code and companion plumbing code to sit alongside the monolith classes. So let me show you an example of that. Jumping into the same class as before, trade action here. So in partition 1, there it is again, untouched. The same monolith class is being placed into partition 1 because that's how my recommendation or my customized view says it should be. Trade action is in partition 1, right? Now alongside it, it generated this trade action service class. Now what is that? Basically, if I go to the same method there, it's essentially a JAX-RS-based web service wrapper for the monolith method by. So here, that's the wrapper here. And if you keep looking at the implementation under the covers, ultimately it calls out to the monolith class and the by method. So now because this class is external facing, meaning if I click on trade action here, it takes on a special meaning to Mono2Micro's code gen because although it's heavily trafficked by classes within its own partition, it's also called into from classes outside of its home partition. So once there's more than one occurrence or one or more occurrences of that where external calls are coming in, that class now gets classified as a service class, i.e. it's external facing. So therefore, Mono2Micro will generate that service wrapper alongside it. So to go along with that, the other partitions now still expect to be able to compile against and call into trade action. So what happens there? So let me go into one of the other partitions, partition 3. And I go to the same place where I expect to find trade action, because this again follows the same directory structure as a monolith source tree. If I load up trade action here, this is a completely generated class. There's no original monolith code here at all, and this has been generated by the monoliths by the Mono2Micro code gen tool. And if I go to the by method there, this now, as you might imagine or expect, it acts like a Jaxara's web service client. So the method's signature is the same as the monolith class's by method, but under the covers, it acts like a Jaxara's client, and it calls out to that service. So as a whole, what happens is, if I go to this slide here, your monolith starts off as, of course, one VM, a bunch of classes running in one VM and one app server instance, very likely, with method calls between them, between classes. And once it's broken up into partitions, for all the classes that are external facing, what used to be method calls are now REST API calls using Jaxara's web services. All right, so that's basically how our CodeGen works. It also takes care of all the object lifecycle and the instantiation of the actual monolith object. Let's say, for example, for trade action here, the instance of trade action will only live in this partition, of course, whereas there's a proxy on these other partitions. And then the code, the generated code in here will track its lifecycle and garbage collection and whatnot. So that's all taken care of for you by the generated code. So this works like RMI in the sense that what used to be in RMI stubs and skeletons are now Jaxara's services and clients. All right. Once again, I'll quickly pause there if there are any questions that I need to answer. Marika? Okay, I guess I'll keep going then. Right, so now that we have generated the code, that also is runnable on the command line like our other tools. What do we do next? So obviously, Mono2Micro's CodeGen takes care of all the Java code and the Java artifacts in your source tree, but what about the non-Java artifacts? So Mono2Micro does not get into the business of trying to refactor or copy or modify your non-Java artifacts. So that's where some user work is required to further refine and finish the implementation of these partitions in order to get them up and running in containers, right? So let me quickly speak to how we advise users do that. So just a quick recap here, on the monolith source tree, there's all these other non-Java artifacts, like the POM XML. In this case, this monolith application is using Maven, so there's POM XMLs. At the year level and the module level, there are Java EE deployment descriptor XML files, the server config files for Liberty, and so on and so forth. So what we advise the user to do is take all of those non-Java artifacts in your monolith source tree and copy them wholesale into each and every partition. And this is where the fact that these partitions maintain the same directory structure comes into play and is helpful. Copy them wholesale into each and every partition, and then start to reduce the content within them so that the remaining content only applies to that partition's functionality. So to explain that a bit further, let me jump into this slide here about how I've done the day trader application and how that's been refactored, right? So on the left here, you see the monolith. It's got a year module, of course, and within it, EJB and web module, and some of the important files within there are like the POM XML, the EJB XML, and the source code. There's also POM and application XML at the year level, and a server config file as well. All right, so now once refactored into these 4 partitions that I showed in the UI there, now I know that the EJBs are only going to be running in partition 1. That's where all of my EJBs and JPRs are now placed, right? So of course, that can still continue to be an actual EJB module with the EJB XML and whatnot. But in all the other partitions, although it takes on the same name because we're keeping the same naming structure for the modules and the subdirectories, it doesn't really have to be an EJB module anymore. It's essentially just a utility module because all the code in there is just proxy code that calls out to partition 1. So therefore, you can remove the EJB jar XML altogether in the config here, as well as modify the other build and Java EE config to reflect that. And similarly, the web container is now where all my UI code lives. So that means all of the UI config and non-Java artifacts and all the other partitions don't need to be there anymore. So that's a kind of reduction of content I was talking about, where everything in here is copied into all 4 partitions wholesale, and then iteratively try to reduce the content down to what is only needed for that partition. Once all of that is done, essentially each of these partitions now is a mini year version of the original entire year on the monolith. Now we can containerize them and run them in Docker, and now you can stand them up as 4 separate containers running and providing the functions the same functionality as what the monolith did. One other change that I did here was it used to use a file-based Derby database. I could have, if I wanted to, kept using that and only in partition 1, but I also chose to containerize that in its own container as a DB2 database so that other partitions can talk to this if needed in the future. So quick example of how I did that, coming back to my VS Code here, I'm going to pick partition 1 again, and I'll just show you quickly the Docker file. There it is. It's a simple Docker file. I'm still using the same build config. It's still Maven based for each of the partitions, but I now wrapped that inside our Docker file to extend from a Liberty microprofile image. And now each of these images can be run on their own. So in fact, if I show you a Docker PS here, I've been running these 4 partitions already, partition 1, 2, 3, and web. And what you've been seeing here before as the running monolith is in fact the refactored version. And it behaves and acts pretty much the same. Of course, there's going to be some parts of it that might need to be fixed up still. But what you'd expect is because the same monolith code is being used in the refactored partitions, like from the monolith, the same functionality should be there once they're up and running. And in fact, the same use cases that you ran on the monolith can now be used against the refactored running version to validate that everything's still working and use to debug further and fix up things further. All right, so that's pretty much the end of my live demo. Are there any questions I can answer?
Yes, there is a question. What is the best way to establish communication between microservices, HTTP, RPC sockets, etc.?
Right. So in this case, for Mono2Micro's CodeGen, we use HTTP REST APIs, and based on Jaxar's web services, you can choose to use any Java communication mechanisms you want that can do microservices, but the CodeGen uses Jaxar's based web service communication technology. Hopefully that answers the question. Any other questions?
I don't see anything, but guys, please feel free to put your questions in the chat, and Len will be answering them. So for now, that's the only question I see.
Okay. So I did want to point out again some useful links as part of the deck. I believe that'll be shared with you. Our landing page is ibm.biz/Mono2Micro. Please go over there and you'll see more information about the product and also how to get started on the 90-day free trial. There's also an interactive demo linked from there that you can try out for yourself, especially the UI and how to view the recommendations from the AI. And this is the link to the end-to-end tutorial that I just did, but of course in more detail. And we also have a lab that you can try out that's based on a smaller application, and some articles on the technology behind Mono2Micro and also the AI as well. Okay, I guess if there are no other questions.
I will also add those links to the chat for the people as well to pick them up. Let me see one more time here. Yeah, I saw a question. Could you deploy the output of IBM Code Engine? So let me ask the question again. Could you deploy the output on IBM Code Engine? That's the question.
The output meaning the generated code on IBM Code. I'm not sure if I followed that question properly. Could you explain a bit more, please?
So the person on this chat, leave. If you can explain a bit more, would be helpful for us. So can you, let me give him a couple of, 1 minute here. So Lee and Michel van de Hoogten, if you can please add something here, would help us to answer your question.
But I'll try to answer it in a possibly too general sense here, but hopefully it'll be helpful. I mean, the code that we generate is basic Java code alongside some basic Java EE features like the JAX-RS web service features. So as long as you have a platform and framework that can handle that, it can be deployed on that. And of course, all of our tools are geared towards deploying and running the generated code and the implemented partitions on WebSphere Liberty. That's our target.
Okay. And I've seen here something says difference event-based and microservice architecture. Okay, so here I got something. Okay, so he said indeed the generated code could it be used to run on IBM Code Engine?
So maybe I can come back to that question if I don't think I have an answer for that right now, but I don't think there should be anything blocking it from running on IBM Code Engine.
Okay, so so I think that is the answer is yes, it could be most likely. Okay, and we can put also the answer on the YouTube, I think, as a comment at the end.
All right.
I'm going to take that, copy here. So anything else? Let me look if okay. Any other questions? Again, please put them on the chat so we can answer them. I'm not sure what you mean here. Naja Farah, use COBOL.
Oh, so was there a question about COBOL? Is that what I'm hearing?
Yeah, just says use COBOL. That's it.
Right. Okay. So just to be clear here, the IBM Mono2Micro tool as part of the WebSphere Hybrid Edition is completely Java and Java only. We only support Java. That's what the runtime support. So there is no COBOL support if that's what the question is.
Okay. We have one more question here.
Mm-hmm.
Okay, so the person here could not really didn't follow from the beginning, but he's trying to ask us here: can we apply this approach to a current microservice approach to identify potential new partitions, or way to validate the current architect?
So can you read that question to me one more time? I believe the question is about if this approach can be applied to an existing microservice to further refactor it. Is that what the question is about?
Yes, to an existing microservice approach, yes, to identify potential new partitions.
Right. So if you have a fairly heavyweight and large microservice, and that's in a sense a mini monolith, if you will, or a Java application on its own right, definitely the same approaches and practices can be used to further refine and refactor it using this approach. Yes.
Okay, beautiful. So the answer is yes. Again, any more questions? We still have a bit of time here. So let's give 1 more minute for in case people want to ask. Okay. All right, so I see another one here. Okay, it says here, if this indeed works, then you could possibly fully automate the legacy modernization of Java EE into a cloud-native application running on code engine without any manual intervention, even for the run?
Well, that would be one of the ultimate goals. But again, I want to just clarify here. Obviously, the refactoring of monolith applications, especially complex monolith applications, to ideal microservices, there's no AI or automation currently out there that can rewrite code for you to be completely independent, stateless microservices, obviously. But where Mono2Micro comes into play is it greatly accelerates that journey for you in terms of refactoring the app and getting started on implementing the partitions with some manual further refinement and implementation. But yes, ultimately, this is what we want to get to.
Okay. Okay, so let me give 1 more minute again in case there are more questions coming. And I'm also providing the links that Len has here to help you pick those
Great.
up as well. So let me give 1 more minute, and if not, then that would be the end of this episode or session. Okay, so guys, you have a minute. Please take advantage and ask your questions.
Yep, ask away, please.
Okay. Okay, let me see. Okay, he said, okay, understood. So this is one of the questions that was asked, right? So he's answering there. Okay, understood. Still would strongly reduce the effort. Really great. Thank you.
Yeah, absolutely. That's what we aim to do here. Yeah.
Wonderful.
So I'm glad you appreciate that. Thank you.
Yeah. So all these, yeah. Thanks to everyone here, guys. You are being wonderful. So it looks then that this. Oh, okay. There is here. Are there any design patterns to follow? Is it better to create data layer separately and write the use cases separate microservices?
Okay, great question. So let me dive into those aspects a bit here. Coming back to my UI. So in terms of design or patterns, I think one question was about patterns, right? So one pattern so again, once you have done the use cases collection, coming back to my slide here, if you only chose to run use cases for a certain set of functionalities in the monolith, or maybe even only just one functionality in the monolith, then obviously the rest of the monolith code is going to be classed as unobserved by the AI. And you're going to see that in that giant unobserved partition. And then the code that you did exercise might try to be further partitioned or kept as one partition. So that's one thing about use cases. So obviously, it is better to provide use cases that exercises as much of the application as possible in order to give Mono2Micro the complete picture before it can start to do its recommending business. One other thing I wanted to mention is in terms of how you want to go about patterns in terms of partitions. Say, for example, you wanted to employ the strangler pattern, and that is a good way to get started on refactoring, if you will. And whereas the Big Bang approach is to try to refactor everything all at once, the strangler pattern says, okay, you want to identify maybe 1 or 2 key functionalities that can be extracted out or strangled out of the monolith as a microservice, right? And for that, you can use either the natural seams view, which might be more appropriate for it, or even the business use case view, where you can say, you know what, I like this island of classes here, and that identifies the one microservice, or at least a good base of it. So I can then move everything else into one partition to remain as a monolith and just work on this one as a microservice. And you can do that even with the business logic view as well, where islands of functionality or one island of functionality can be identified to be strangled out as a microservice, even though it might have existing crosstalk, but at least as a starting point, you can do that. So there are various patterns that you would normally use when trying to manually refactor monoliths can be used with Mono2Micro as well. Hopefully that answers the question.
Okay. All right. So again, I hope that this answers the question. As Len said, if anyone has another question, please put it here in the chat. So I'll give 1 more minute again. Okay, it looks, these are all the questions. Does not look anyone is providing new questions here. So I guess we're all good then. So again, please have a look at the useful links that Len has provided. Hopefully you will find those useful. And that's, I guess that's it, Len. Is there anything else you wanna let us know before?
No, that's all I had. Thank you.
Thank you. Thanks, Len, for the presentation, and thank you all for the good questions that you have asked. And hopefully you find this session useful. Have a wonderful day. Bye-bye for now.
Right. Bye.